So to prep you for these real-world examples, let's read through some examples. So when you're reading the word problem, it's going to say something like the velocity of a car after traveling for 1 hour is 50 miles per hour. So what are they giving you there? Well, you have to give a variable to the distance traveled, so they called it x, and they're calling dx dt, that would be your velocity, right? V, well, really that's what it is 50 miles per hour, and then it says you've been traveling for 1 hour, so that gives you that t equals 1. So in reading that sentence, you need to see that a rate of change is 50 and time is 1. Be able to pull two things out of that. Let's look at this next one. It says water is being pumped into a swimming pool at a rate of 10 cubic meters per hour. So it's cubic meters. Cubic means I'm talking about volume. So they're giving me the rate of change of volume, so dv dt, or v prime in this case, and they're telling you what it is. It's 10. A gear is revolving at a rate of 25 revolutions per minute. And then it says 1 revolution equals 2 pi rad. So in 2 pi in terms of radians, okay? So if theta is the angle of revolutions, then it's giving you d theta dt is 25 times, well, we need 1 revolution, which would be 2 pi rad per minute. A population of bacteria is increasing at a rate of 2,000 per hour. So whatever our population is, they call it x here, we know its rate of change, x prime, would be 2,000 per hour. Notice every one of those are labeled. So, what do I expect you to know? What do I expect you to know? If you don't know it, put it on your note card if you're allowed one. What I expect you to know is the following formulas. The area of a circle, a equals pi r squared. The next one says the perimeter of a circle is a equals 2 pi r. That's totally messed up. First of all, it's not called a perimeter of a circle, it's called a circumference. The circumference is the outside of a circle, and that's not a equals, that's p equals 2 pi r. Okay, so that's what it is for the perimeter of a circle, or it's pi times the diameter, whatever you want there. I expect you to know the volume of a sphere, a circle, right? Three-dimensional circle, so the volume is 4/3 pi r cubed. The volume of a cube, well, really what I did was a box here, so I said length times width times height. But really, in a cube, that means all of your sides are the same. So you'll usually see s cubed for the side length cubed. And then I certainly want you to know Pythagorean theorem. This is when you have a right triangle A, B, and C, with A and B being the legs, C being the hypotenuse, and it has to be a right triangle for the Pythagorean theorem to work. So let's see some examples here in action. It says, a pebble is dropped into a calm pond, causing ripples that form concentric circles, as shown in the figure. So look at the figure, and you can see that it's making circles. It says the radius of the outer ripple is increasing at a constant rate of 1 foot per second. So they're giving us the rate of change of the radius, in other words, r prime. It says when the radius is 4 feet, at what rate is the total area of the water changing? So they want the rate of change in area. They want a prime. What have they given us? Think about what they've given us. They told us that the radius is at a rate of 1, so they're telling us r prime equals 1. We're going to look at the measurements in just a little bit. And then it says the radius, when the radius is 4. So we have r equals 4. So there's our given information. The radius is changing at a rate of 1 foot per second. The radius is 4. We know they want the rate of change of area. So the question then becomes, what do we do from here? So this is where we need to start thinking. And what do I mean by thinking? Here's what I mean by thinking. We have to find an equation. So what equation represents this? Well, they want the equation. We're trying to find the area of what shape? A circle. So you have to remember the equation of a circle is a equals pi r squared. At this point in time, do not plug in a single number. You never plug in a number until after you have found the derivatives of both sides. So what we're going to do is we're going to find the derivative with respect to t of both sides of this. Again, every single variable, you need to put a prime there. So what's the derivative of a? The derivative of a would be a prime. What's the derivative of pi r squared? Well, remember, pi is just a number. So we drop the power, so that would be 2 pi r to the first power. And then we need to multiply that times r prime. Don't forget your chain rule. So I'm getting the derivative of the equation to be a prime equals 2 pi r prime. Now that I have put everything in, or taken the derivative of both sides, and only now can I actually go back in and plug in the given information. So we know we would have a prime equals 2 pi times the radius was given as 4, times the rate of change in radius, and that's a 1. Okay? So what do we have? Well, 2 pi times 4 times 1 would be 8 pi. So if they wanted the exact answer, it would be 8 pi. They don't really say, right? So I don't know if they want an estimation of this. So I don't know if they want the decimal approximation of this or the exact answer. They didn't say, so I'm okay with you leaving it as 8 pi. Or you could have put this into your calculator. So I'm going to put 8 pi into my hit pi, I hit enter, it gives me 8 pi. Just hit the double arrow button above enter. And once I hit that, I get approximately 25.13. Now this is area, so let's think about it. It's always with respect to time. So what was our time measured in terms of? That was measured in terms of seconds, right? And then this is area. So in both the r and the r prime, we had feet. Area is always the units squared. So in this case, it's feet squared per second. So what is my area changing at? Approximately 25.13 feet per second, feet squared per second. And if you look in the book, it seems to me that they left it in the exact one. They actually left the answer as 8 pi. But if someone ever asked you a rate of change, would you ever say 8 pi? So it's not really realistic there for their answer. I'm okay with the decimal approximation on that one.